So we distribute the negative 2 to each term. 2x minus 8 is equal to x plus 10. Now, there's a reason why I put this problem there. What do we call it when we have 2x and we subtract 2x? Don't say cancel. Don't say cancel. What is it called when we add the opposite terms? It's called elimination. So sometimes we don't use that word. And I was just joking about don't say cancel because most kids they say oh these two cancel each other out, but actually in reality the correct phrase is they eliminate each other, right? So if you have a positive 2x and a negative 2x, they eliminate each other and you're left with just 0. So now our equation is negative 8 is equal to x plus 10. Subtract 10 from both sides. X is equal to negative 18. Okay, how many people got that? Good. Okay. So that's the proper term is elimination, right? Which leads into our lesson today. So notice things will eliminate if they're opposites of each other, a 2x and a negative 2x. All right, let's see how about the graphing. So m equals 2, b equals 0, 4. So 0, 4, up 2 over 1, up 2 over 1, up 2 over 1. Down 2 over 1, 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 down 2 over 1. And m equals negative 1/2. And b equals 0, 9. Down 1 over 2, down 1 over 2. I already got my answer. So that's at 2 and 8. Okay. Now, there's something special about those lines. Anyone know? You can kind of tell by looking. There's a certain word that relates to them. We didn't do it this year, but normally we do cover it. There's a special relationship between those two lines. It has to do with the slopes. But again, we didn't cover it this year, but I want to see if anyone, maybe for previous years. Okay, it's about the way that they intersect each other. Has anyone seen that before? Give you a hand that starts with the letter P. That's not parallel. Perpendicular, yeah. So these are perpendicular lines, which means that they intersect at a right angle or a 90-degree angle. My drawing did not do it justice. Maybe yours did. And the reason we know that is because the slopes are opposite reciprocals, okay? Again, we couldn't cover it this year. We ran out of time. All right, and lastly, substitution. Remember, y is y. They are the same thing, which means that whatever y is equal to here, this y will also be equal to that. So 6x minus 9 is equal to negative 3x. Subtract 6x, subtract 6x. Negative 9 is equal to negative 9x. Divide both sides by negative 9. X is equal to 1. Substitute it back in to find out what y is equal to. Y is equal to negative 3 times 1. Y is equal to negative 3. So my solution is 1 comma negative 3. And you can do your mental check. Yes, that works. Okay. All right, so this is all review. And like I said, I know most students, they don't like it doing new notes before they take the quiz on the current topic, but this will help you do better on your quiz on Friday. So where do we go from here? So far, everything seems good. We're graphing, we're happy, we get it, but there's more to this, okay? So Dia, can you please continue reading? What if Oh, you keep going. I'm sorry, yeah, I was distracted. Thank you. So there's a third option. So you guys saw this a little bit on the last two class kicks, where you're like looking at it and you're like, man, do I solve for y? Do I solve for x? Do I solve for x? Do I solve for y? And there was like no good option, because if you did solve for either of those, you would get a really nasty fraction. And most of us, when we see fractions, we curl to a fetal position and start sucking our thumbs. It's just like we're just scared of fractions, right? There's no reason to be scared of them, but I get it, right? It could make it a little tougher. You know, it's hard to put things in your calculator. So now we have a third option that's called elimination. And the way elimination works, just like as Dio was reading, is it eliminates the opposites if you create opposites for variables. And it's actually a pretty nice way to solve. And so most of you guys are going to say, Mr. Bass, why didn't you just show us this the first time? Well, sometimes substitution is the best way to solve. I can't tell you which one's the best way. That's for you to figure out. But I'm giving you options, okay? So, Gabby, can you please read step one? Okay, so we already have that. So like Gabby said, if necessary, it's not necessary because negative 5y and positive 5y are opposites, right? Just like in above, 2x and negative 2x were opposites, okay? So before we can get started, we have to make sure that we have at least one pair of variables that have opposites, okay? And we may need to multiply by something in order to create that. All right, thank you, Gabby. Next, Dimitri, step two. Okay, so we're going to add the two equations. In fact, we always add. I wrote subtraction in there because I was trying to be like as close to the book as possible, but I've never subtracted it. We always just add them because when you add, the elimination is going to happen. So I'm going to add these two equations together. So negative 3x minus 4x is negative 7x. Negative 5y plus y. What's the word we use? Like you said, and everyone else, what's the word? What happens with these two? They are, everyone, eliminated, right? They are eliminated, right? Which is the name of the game, right? So these are eliminated, and look what happens. We have one variable left, just an x. The y's are eliminated, okay? So Tommy, can you read the next one, please? All right, well, this is a one-step linear equation. Just divide both sides by negative 7, and we get x is equal to negative 1. All right. And then, Marie, can you please say the last step here? Okay, thank you, Marie. It's important that we do the original equation because sometimes when we manipulate it, we can make a mistake. So in this case, it doesn't matter which one I substituted into, either this one or this one, but it's the original one, and they're all original. So negative 3 times negative 1 minus 5y is equal to negative 7. This is positive 3 minus 5y is equal to negative 7. Subtract 3 from both sides. Negative 5y is equal to negative 10. Divide both sides by negative 5. Y is equal to negative 2. And there really should be a step 5 here, which is write solution as ordered pair and check. So the ordered pair would be negative 1 comma negative 2. And now I do a mental check. So negative 3 comes over 1. It's positive 3, positive 3, minus, oh, it's positive 2. That, see, that's why we do the check. Negative 5 times 2 is negative 10. 3 minus 10 is negative 7. That works. Negative 4 times negative 1 is positive 4, plus 10 is 14. That works. So yes, this is the solution. All right. So just at first glance, how many of you guys think that this is easier than substitution? How about in the virtual world? Just from this first example, how many of you guys think like, oh, this is way easier than substitution? Why did you just show this the first time? No, I always get that. Yes, I know. I know. Okay, well, let's take a look at a more complicated question. So following the same steps that everyone in the class has read, we want to find an opposite. And as Gabby read earlier, we may need to multiply if necessary. So looking at B, okay, and there's no wrong answer. All right, so Zach, D, is there a variable that you're looking at, you're like, I think we could get rid of this one. Which one? Y, okay, good. So look at this problem here. We have a 3y and we have a negative 6y. They're so close to being opposites. But if I just multiplied one of the equations by a number, I could get the opposites. So again, you could multiply by 1/2, but I wouldn't do that. I always try to stick with integers. So what is the opposite of negative 6y? 6y. And what do I have to multiply 3 by to get 6? 2. 2, because I need the opposite. So I need to multiply by 2. So now I get negative 20x plus 6y is equal to 2. Most students, they forget about multiplying that 1. If you do that, you're not going to get the right answer. So you have to make sure that you're really paying attention to what you multiply by and that you distribute it to every single term. So now I made a new equation. My first equation is now negative 20x plus 6y is equal to 2. And my bottom equation stays the same. And look, the whole point of doing that is we just created an opposite, 6y and negative 6y. And once you do that, we can just add them together. What happens to 6y and negative 6y? They are eliminated. And now we're left with negative 25x is equal to 25. Divide by negative 25, divide by negative 25, x is equal to negative 1. So a simple one-step equation, and we already found x. And to find y, I just substitute it into any of the original equations. Remember, it's the word original that I need. So, Jody, which equation do you want to substitute into? The first one or the second one? Okay, second one, let's do it. So negative 5 times negative 1 minus 6y is equal to 23. 5 minus 6y is equal to 23. Subtract 5 from both sides. Negative 6y is equal to 18. Divide by negative 6, divide by negative 6. Y is equal to negative 3. And we have negative 1 comma negative 3. And before I put it in the box, I should have done this. Okay, so let's see. That's 10 minus 15. Or 10 minus 9 is 1. Okay, that works. 5 plus 18 is 23. That works. Okay, so this is the right answer. Okay. Now, C is the most extreme type. I don't even know if you guys ever get one of these because this is kind of a weird year, but it's good to see a challenge question. Okay, so here, in my mind, I see something that's a little easier to work with, but there's no wrong answers. Okay, so Olivia, is there anything that you're like kind of like leaning towards of which variable to eliminate? Why? Okay, so this is where you got to be really creative and you got to think about, well, how can I get y by itself? Because right now, we have a negative 3 and a negative 2. So how could I create opposites? I'll give you a hint. You have to do something to both equations. Any ideas, Olivia? 6 is a common factor. Very good. Okay, so they have a multiple. They both are factors of 6, which means I have to multiply both of these by a number to make one of them positive 6 and one of them negative 6. And it doesn't matter which one you do to what. They just got to make sure one's positive and one's negative. So, is it okay if we do this by -2 and this by +3? So now, again, most students forget about these constants over here. Don't do that. Double check your work. Distribute to each and every term. So now I have -8x plus 6y is equal to -16, and 15x minus 6y is equal to -33. Yes. There's one right there underneath VSC. Zach and Dia, do you mind just scooching your desks forward a little bit and having Victor go up? Right, so 7x, these are eliminated, which is the whole name of the game, is equal to -49. Divided by 7, divided by 7, x is equal to -7. And then we substitute it into the original equation. So none of these, we just created those. It has to be one of the originals. Okay, so Peyton, which one do you have a feeling about? Top or bottom? The substitute in. Okay, so 4 times -7 minus 3y is equal to 8. So -28 minus 3y is equal to 8. Add 28, add 28. -3y is equal to 36. Divide by 3, divide by 3. Y is equal to -12. So -7 comma -12. And let's check. So it's -28 plus 36 is 8, so that works. And then -35 plus 24 is 11, that works. Okay, this works. All right, so we are going to go over A, B, and C, but I want you guys to try those out first, okay? So let me give you guys like 10 minutes. Try A, B, and C. A is the most simple version. B is a little bit of work, and C is the most amount of work, okay? So try those. All right, Victor, I'll talk to you outside. Oh, I'm sorry. I'm sorry. Okay, looking good. So in the house, they got a, so far, most people have gotten A down and on the verge of B, so I'll start writing those down. So for A, I already have my opposites, 3y and negative 3y. So x plus 3y equals negative 10, x minus 3y equals 14. These are eliminated. And now I add them together 2x equals 4. Divide by 2, x equals 2. Now I take this 2 and I substitute it back in to solve for y. So 2 plus 3y is equal to negative 10. Subtract 2, subtract 2. 3y is equal to negative 12. Divide by 3, y is equal to negative 4. So this is 2 comma negative 4. Okay. In the virtual world, how many guys got that for the first one? Good. Very good. All right. All right. So now let's all. I can do B. Most people here are finished with B. So if I'm looking at this again, there's no wrong answer, but something attracts my eye here with the 2y and the positive y, and that is if I just multiply this by negative 2, then I'm going to create an opposite for y. Again, you could have done the other x, and that would have been totally fine, but I think it's easier to do the y. So now I rewrite this. 3x plus 2y is equal to 8. Negative 4x minus 2y equals negative 10. Again, the most common mistake with elimination, which is why sometimes students don't have success with it, is they forget to multiply the constant by the number. You can't forget that constant. So now when I add these together, okay. When I add these together, 2y minus 2y is eliminated, and I get negative x is equal to negative 2. Divide both sides by negative 1. X is equal to positive 2. And then we substitute it into, it doesn't matter which equation, but again, I kind of think that this one is a little bit easier. So it's 2 times 2 plus y is equal to 5. 4 plus y is equal to 5. Y is equal to 1. All right, so I'm doing my mental check here. 3 times 2 is 6, plus 2 is 8. Yes. 3 times 2 is 4, plus 1 is 5. Yes. All right, so how many people in the virtual world either got 2-1 or on the verge of getting 2-1? How about the real world? How many guys got that? Good. All right. A little bit more time on C. Okay, it's a little trickier. There's a certain way that I'm looking at it, and I'm like, I think this would be the way to go, but so like, oh, by the top by 3, good, and the bottom by 2. Cool. Yeah, it's not going to be. Oh, because you made it a negative 27. That's 35. 7y equals 35. Because I multiplied it by a negative 2. Because yeah, either the negative, you either have triple positive, you're not going to cancel out. One of them has to be negative. So that's why I thought I'm going to multiply this by negative 2. You want to get rid of the 1 thing? Okay. Then you got to be careful. There's no longer one really wise or they're going to look like this. Top okay. All right. So some of you guys in the real world got started on C. If you haven't gotten started, I'm going to make a suggestion. To me, I'm looking at this, and I could either multiply everything by 11 and 5, which could, get bigger numbers, or multiply everything by 2 and 3, which I think is a little bit more doable. So there's no wrong way. If you did 11 and 5, you probably got it right. But to me, it looks easier if I just do it this by 3 and this by 2 to get negative 6x minus 15y equals 27. and 6x plus 22y equals 8. Okay, so let's go from there. Give you about another 30 seconds or so. If you haven't gotten started, I would recommend that. You don't have to do it this way to do it your own way. Okay, all right. So we have, these eliminate each other because they're opposites. 7y is equal to 35. Divide by 7, divide by 7. Y is equal to 5. And we just substitute this in, and with the top one, to find x. So negative 2x minus 5 times 5 is equal to 9. Negative 2 minus 25 is equal to 9. Negative 2x, add 25 to both sides, is 34. Divide by negative 2, divide by negative 2, x is equal to negative 17. So now my solution is negative 17, comma 5. And if you check that, it works. Now, did anybody get that in the virtual world? That's a tough one. Wow, all right. Good. Very good. Okay. How about here? I saw most, some of you guys are on the verge of it. How many guys either almost got it, or you got it, or almost got it? Negative 5? Did you still get a positive 17? Oh. Okay, so I'm going to leave this up because I know there's still some people copying it down. It's totally fine. But there's a reason why, another reason why we show elimination. And it's, not because it's another good alternative, because I think some of you guys kind of like it better than substitution, which is fine. The quiz on Friday is substitution, right? But the problems are set up that way. So there's a reason why it's substitution. Another reason to do elimination is because it's a lot easier to work with real life situations when you do elimination. Okay, so here's what I mean. Ben, are you caught up? So I wanted you to read. Are you caught up? Can you read, or are you still writing? Okay. All right, so we're going to set up a system, and what the system's going to tell us is how many of each supply, how many of each thing that I buy, right? And again, the quiz is, if we put one, it'll probably be bonus. But why don't you guys see the value of elimination? So when we create a system, there's usually going to be, and typically when we have a system, there's going to be like a quantity equation. And like a value or money equation, typically. Again, there could be equations of all types. But it usually comes down to how many of each thing and how much does each thing cost. So looking at Ben's first statement here, it said a combination of 50 pens and colored pencils. So that, to me, tells me that's how many of each. So I'm going to create an equation. So let's call pens P and colored pencils C. So the combination of pens and pencils, pens plus pencils, is 50. So that's the quantity equation. And then there is the money equation. And that's the next line that Ben read. Pens are 25 cents, pencils are 15 cents, and you spend a total of $10.50. So the way we write this is 0.25p plus 0.15c equals $10.50. Yes. Yeah. Okay. And there's our system. And it would have been pretty tricky to do this with substitution or setting it up a different way. But with elimination, you see how things are lined up. And now you definitely need your calculators for this next part. So they have to create an opposite. And again, it doesn't matter which one you pick because it's going to be equally challenging, but you need to use a calculator. All right, so Nikki, which letter, P or C, do you want to solve for first? P, okay. So we're going to solve for P, which means I'm going to multiply this top equation by negative 0.25. And that's going to create the opposite of 25 cents, okay? So negative 0.25p plus negative 0.25c equals 50 times negative 0.25, negative 12.5 over 0.25p plus 0.15c equals 10.5. And again, the opposites eliminate. No more p, I just have c. So negative 0.25 plus 0.15 is negative 0.10c equals negative 12.5 minus 10.5 plus 10.5 equals negative 2. Divide both sides by negative 0.10. C is equal to 20. So that's 20 pencils. And how many pens? That's just the remaining, which is 30, because the total was 50. And with these, you don't write them as an ordered pair, you just write them as words, as a sentence. There are 30 pens and 20 colored pencils. So again, it's an application of elimination. This is why we study elimination, because it's got it's nice to use, right, in this sense. All right, so take like 30 seconds to write this down, finish writing it down, and I want you guys to try one. We won't solve it, but I want to see if you can set it up. Okay. All right, Chris, can you read number 5? And then all I'm going to ask you guys to do is set it up. You don't have to solve it. Okay. Madeline, can you read it one more time? Number 5. Yep. Okay, so I'm going to give you the variables. And I just want you to set it up. You don't need to solve it, just set it up. Okay, so let's see how many guys can give me the system. Yeah. Well, you know, we can. You got it. You think you got it? Yeah. Okay. All right. So let's see how many guys in the virtual world got this. So usually, like I said before, in general, again, it's not a hard rule that, you know, next year you'd be like, well, Mr. Bassler told me this and you're wrong or something like that. That's not what I'm saying. But typically, it's a quantity equation and a value equation. So in this case, the quantity is 20. So P plus C equals 20. You're making 20 of them for your friends and family. And then in the value equation, instead of money, is time. So it takes 1.5 hours for cookies, 2 hours for the picture frames, and the total number of hours you have is 34. All right. So there's quite a few people in the real world that got this. How about in the virtual world? How many of you guys got this? Okay, good. Okay, so now we're moving on to the last part of our notes. I did have a class plan, but it's a lot of it's more notes than I thought. So you guys will just, I'll give you a break at the end of class, and you can work on your extra credit um, quiz review. Okay, so special cases. Of course, we got special cases, right? You can't have just everything working out nice. There's gonna be some times when things don't work out. And we saw this already for graphing, and we saw this already for substitution. So now we're going to see what does a special case look like for elimination. And I can't just give you like a straight up easy one because you guys will see it right away. So some of these special cases, they require you to do something. So looking at 2x minus 2y equals 4 and negative x plus y is equal to negative 2. Braden, which variable do you want to get rid of? Y, okay. So if I notice above, if a negative 2y, this is just a 1. So what do I have to multiply that by to get the opposite of negative 2. So what is the opposite of negative 2? So what do I need to multiply y by to get 2? To make it a 2y? 2, yeah, you're going to multiply by 2. Okay, so now I have 2x minus 2y is equal to 4. Negative 2x plus 2y is equal to negative 4. And I got it. All right. Yeah. So now look what happens. When I add them together, what's 2x minus 2x? It's eliminated, right? 0. What's negative 2y plus 2y? Yeah, nothing, 0. What's 4 minus 4? 0. Does 0 equal 0? Yes. So since this is a true statement, we call this infinitely many solutions. Infinitely many solutions, okay? All right, and this, again, similar to substitution. When we did substitution, the variables were eliminated and we had to have something true. Well, with elimination is the exact same idea. Notice the variables are eliminated, and this time we have a true statement, which is infinitely many solutions. Let's check out B, okay? So Kranza, last one here. Which variable do you want to get rid of, X or Y? Y, and I need to create an opposite. So what's the opposite of 2y? Good. So now what do I need to multiply the top by? Negative 2. Good. So distribute, distribute, distribute. Positive 4x minus 2y is equal to negative 16. Negative 4x plus 2y is equal to 6. This time when I add them together, watch what happens. What's 4x minus 4x? Eliminate it. What's negative 2y plus 2y? Eliminated. So 0 is equal to negative 10. Is that a true statement? No, this is nonsense, right? So you get like a nonsense answer or not a true statement. It tells me that the answer is no solution. Okay. In both cases, the variables were eliminated, but when it was infinite many solutions, it was like a real true identity. We call it an identity. And in the other case, when there was no solution, we got like a nonsense answer. Like it's like, no, that's not true. That tells me it's no solution. Okay. So last two things to try on your own, C and D, and then kind of in your own words, like how do you know if it's infinite many solutions or no solution when you use elimination? We know what it looks like for substitution. What does it look like for elimination? All right, so try C and D on your own. The last two things for the day. Oh, you oh, okay, you could do that. But I just figured you multiply the volume by 2. You could do that. That's fine. Okay, continue. One. This side, yeah. Okay. I want to make sure everyone gets their. Let me see. Okay, it's looking good over here. So if you notice, we already have opposites here. So we just go ahead and eliminate them. So this whole left side becomes 0, the right-hand side becomes 14, and this tells me it's no solution. For D, they're almost there, right? 4 and 2, 4 and 2. It's like, well, if I just multiply this bottom by positive 2, then I can create opposites because the opposite of positive 4 is negative 4. So now my new equation is 4x plus 4y equals negative 8, and negative 4x minus 4y is equal to positive 8. And look what happens. These are opposites, these are opposites, and these are opposites. So 0 is equal to 0, which is true. So this tells me it's infinitely many solutions. All right, so when you're doing your own words, just kind of think about, like, look at these two examples and think about how they're different and how you know it's a no solution and how you know it's an infinitely many solution.